Hi, it's Robin. Today we're going to be looking at MASTEROM, which is a little-known kernel ROM replacement for the Commodore 64. It was developed and sold by a Canadian company called Norland Software Products in Milton, Ontario, around 1987 to 1988. It had been all but forgotten, but fellow Canadian YouTuber MindFlareRetro was able to contact the author and obtain both the ROM and the documentation for the product, which he will be releasing for download. Make sure you check out his video about this discovery, in which I make an appearance. I'll mention it again at the end of the video. So MindFlareRetro asked me to take a look at the software on the ROM. So that's what we'll be doing today. To me, it's interesting technically, but it's also a neat piece of Canadian Commodore history. And the fact that it's from Milton is really interesting to me because that was where my favorite Commodore magazine, Transactor, had its headquarters for several years. And there's another connection with Transactor. This MASTEROM artwork is really great. I assume that's MASTEROM, who is pulling a Samson here, bringing down the Temple of Dagon, or something like that. Now, this artwork looked familiar to me, then I noticed the signature there under MASTEROM's foot. That's John Mustache, who was the cover artist for Transactor magazine for several years. And I always loved the cover art on Transactor. So that's really great to see another piece of art from John. Okay, so what is MASTEROM? Well, here in the instructions it says, MASTEROM is an upgraded kernel ROM chip for your Commodore 64. It's not an add-on. It physically replaces your present Commodore kernel ROM. Interesting that they use the non-Commodore way of spelling kernel. Without changing your computer's ability to run existing or commercial programs in any way, MASTEROM gives your Commodore 64 30 new commands that come to life instantly when you turn on your computer. Hit F1 and up comes a disk directory. Tap Run Stop, no slash, and the Commodore logo key simultaneously, and the first program on your disk is loaded and run. No more defaulting to the dataset. Convert back and forth from hexadecimal to decimal at the touch of a key. Take a snapshot of a text screen and dump it to your printer, even while another program is running in the foreground. Send commands to your disk drive without the tedious open 15, 8, 15 syntax. Load programs with 2 keystrokes. Copy files without loading a copy program. These are just some of the 30 new commands that MASTEROM 64 gives you instantly when you turn on your Commodore 64. MASTEROM is the kernel ROM Commodore forgot to put in your Commodore 64. Can you life without MASTEROM? Not likely. Now, as I mentioned in MindFlareRetro's video, MASTEROM is based on the version 3 C64 kernel that is the final kernel version that Commodore released. Out of the 8,192 bytes in the C64 kernel, 1,801 bytes have been changed. That's about 22% different. So how did they fit all these new commands in? What they did was remove all the cassette code in the ROM and replaced it with all this new functionality. As it says in the manual, residing in the cassette ROM locations, MASTEROM 64 does away with the cassette deck. The cassette becomes an illegal device. MASTEROM 64 does not, however, prevent the use of the cassette port for the powering of interfaces or dongles, or the use of the cassette buffer for the storing of data. All the chip space devoted to cassette interaction is now devoted to improving the performance of your Commodore 64. To further compatibility, MASTEROM 64 gives up control of its special keys if other programs also use these keys, or the =K command disables MASTEROM 64 altogether. Now, here in Canada and in the USA, very few users in 1987 would care about missing out on the cassette drive. By 1985, virtually all Commodore 64s in North America would have been using a disk drive, as I've talked about in previous videos. Of course, this would not be a popular upgrade for people still using cassette, especially in the UK. Incidentally, Jiffy DOS, which was a much more popular ROM upgrade, does the same thing. It overwrites the cassette routines with the new enhancements. Now, I don't have an official MASTEROM ROM upgrade, which I'd have to open up the C64 and put that chip in. Instead, I've installed it here on this EasyFlash 3, which has a special feature that allows you to replace your C64's kernel ROM temporarily with a ROM on this cartridge. It's a very handy feature, and I made a lot of use of it in the video I did about all the different Commodore 64 kernel variations. So we're going to use that again today. So the EasyFlash 3 menu shows the different kernels up in the top left corner, and option 8 is where I've installed the MASTEROM binary. And here we are, we're booted up in MASTEROM 64 version 3. Okay, so I'll demonstrate several of the MASTEROM enhancements, and then we'll do a bit of ROM disassembly and see how some of it works. So if you press F1, it'll clear the screen and do a disk directory. That's all the files on my SD card from years of making 8-bit show and tell. Now, if you don't like it clearing the screen, you can also do equals $, and it won't clear the screen first. You can press stop to interrupt it. Many of the MASTEROM commands start with an equals, but you can also use the @ symbol if you're more familiar with other wedge commands. And there's a couple other tricks here. While the directory is scrolling, if you hold down Control, it'll pause and resume by tapping it again. Spacebar also does the same thing. Okay, and if we have a little program like print hi, we can list and run it. Now, if we accidentally type new, then we can do the command equals O for old, and the program will come back and run it. You can even do the equals X command, which does a reset of the computer, just like sys64738, which also gets rid of your old basic program. And again, you can go equals O. So your basic program can even survive a reset if you do that accidentally, or if your computer crashes and you do a reset. Okay, you can also toggle between device 8 and device 9 just by typing equals P. That's like a tongue stuck out emoji there, if you happen to have a second disk drive. Now, because the cassette's being eliminated, normally when you type load, that defaults to device 1, which is the cassette. But in this case, we're now defaulting to device 8. So if we type load, it'll now complain that you're missing a file name because disk insists on a file name, unlike cassette. So we can just type something like load SuperMon 64, and we don't have to add the (8) because that's the default. Notice that this does not have a fast loader at all, which after being used to Jiffy DOS is really quite a drawback. There's a built-in file copier, where we could type in the file name that we want to copy, and it will load it into RAM, and then when you're prompted OK, you could stick a different disk in the disk drive. That's pretty neat to have a built-in disk-to-disk file copier. You can just press stop to escape from that. We also have built-in base conversion. If you put equals number sign and then follow it with a decimal number, it'll print it out in hex. So that's C1000 hex. And if you do equals H, then you can type in a hex number after, such as C1000, and get the decimal equivalent back. Suppose they didn't use equals $ because that's already the disk directory. So that's why they're using H here for hex. And also, if you want to know the value of a character, you can just type it between quotes, and it will print it out both in hex and in decimal. That even works for the graphic characters, like so. D1 hex or 209 decimal. Notice you don't put an equals in front of that command. So you can also just use a slash for a load. So we'll load SuperMon 64 again. There we go. SuperMon by Jim Butterfield. We'll run it. And SuperMon installs itself into memory. We'll be using this a bit more later. SuperMon reports the sys address that it lives at. And we can make use of that with this J command, 38169. And now pressing F8, that is Shift F7, will automatically jump to that address. So now we have like a hotkey to start SuperMon. Another interesting thing is if we generate a disk error, like if we try to save a file with wildcard question marks like this, it immediately reports back that the file exists and the error light is not flashing. Now, if I was to reset and go into something like regular Jiffy DOS and try the same command, I have to add the .8 on Jiffy DOS. I don't know if you can make out, but the error light is blinking there. I turned off my studio lights, and maybe the blinking error light's a little bit more clear now. And if you type @ to read the error channel, the light goes out, and now the error prints. File exists. So that's something that MASTEROM does differently. So you can decide for yourself if you like that better. Now these default colors of black on gray, the author really must have liked those. And if you try to change them, like we change the cursor to white, and if we poke the border to cyan, if you tap Stop Restore, it goes back to black on gray. Or here you change the cursor to purple. If you hit F2, it sets the background and cursor color back to black on gray. Those are hard-coded, so I guess you better like them. Maybe they're better than the default blue on blue, at least. Now the instructions say that F3 clears the screen, but actually what it does is clears the screen and lists the current program. We don't have one in memory right now. Okay, so if I press F3, there it lists the program. F4 will clear the screen and run the program. Now F5 supposedly sets a point, and then pressing F6 will clear that line, but I'll try it now. No matter what I try, F6 always seems to just clear the entire line. So I don't know if the documentation's wrong or I'm not using it correctly, but that's how it works. Now on the other hand, if I fill up a line here and move the cursor, say, to this spot and press F7, it does clear the end of the line. So that's potentially a useful editing feature. Okay, so that's most of the MASTEROM features. There's also a couple printer features, but I don't have the printer set up today. Let's load up SuperMon and just explore the ROM a little to see how this was implemented. I showed a few quick examples in MindFlareRetro's video, which I'm sure you're going to be watching soon if you haven't already. So I won't repeat those. So here at ECE7, this right here is the load command. That's actually supposed to be quotes, which is now printed when you press F1. Up in the corner, I'll show a regular C64 ROM has the pattern load, carriage return, run carriage return, so that when you press Shift Stop, it's automatically load from cassette. Instead, this is doing a disk load. So that little string has been replaced. Another simple example is at F0D8, a regular C64 has the text here, press play on tape, and press record on tape right before these messages about loading, saving, verifying. Well, to make the most of every byte, because those tape text messages weren't required anymore, the text was replaced with code. So now, F0D8 now contains some of the code for these features. I'm actually not sure what this part right here does. That turns on reverse characters anyway. Okay, so there's dozens of little differences like those ones and the ones I showed in MindFlareRetro's video. But how are these extra commands actually implemented? How are they hooked in? Okay, well, we'll find that here at memory location 300, specifically here at 0304, which is the iCrunch vector, which is the routine that crunches the Petsky text of keywords into tokens. Normally this points to the basic ROM at A57C, but instead you can see it's pointing to F7 to C in the kernel ROM. So this is part of how the C64 was designed. Several behaviors of the 64 can be redirected to custom routines so that there'll be new behaviors. So instead of the normal parsing routine, when you type in an instruction, it's going to go to this new routine in the master ROM. Okay, and just a little ways down here, it's going to compare the next character with 3D hex, which is the equal sign. So if the parser encounters the equal sign here, it jumps to this F7BD, which handles the new commands. And it also checks for character 4D hex, which is the @ symbol, and also jumps to the same F7BD. So as mentioned before, you can use either equals or the @ symbol to call any of these special MASTEROM functions that I was demonstrating. Okay, and it continues with the parsing. It looks for a slash, which is the shortcut for a load command, and if true, branches off to this routine to handle it. The up arrow, which is actually skipped over the instructions, checks for character 22, which is the quote, which it uses in that ASCII conversion. Whoops. And 2A is the asterisk, which it uses for some printer commands. So you can see how this extra ROM space is being used to parse all these extra commands and then to branch off and actually process them, again, all in that same area of F7 hex here. There's a bit more down here. For example, this 50 hex is checking for the Petsky character P, which is that drive toggle where it jumps between 8 and 9. And actually it handles it right here, and this is a simple routine to look at. The accumulator is loaded with 8 for device 8, and then it checks that against what's stored in 0-page location BA, which is the default or last used disk drive. And if the drive is not equal to 8, then it does an exclusive OR to toggle that to 9 and then stores that back in BA. So it just has the effect of toggling between 8 and 9 each time you run this P command, and then a logical OR is done with 30 hex, which has the effect of adding 30 hex to either the 8 or the 9, which turns 8 or 9 into its Petsky equivalent of 38 or 39, and that's printed to the screen. So it just prints 8 or 9 on the screen. That's a pretty simple function. Here's another one at F8AB, which checks for the character H, which is the hex to decimal conversion, and then it prints out the number sign, which shows it's doing a decimal conversion or conversion to decimal. Prints it out here. Okay, and then it calls this F8C5, which fetches 2 hex characters, pushes it on the stack, fetches another 2 hex characters from the input, then moves them into A and X, and then calls this BDCD routine, which is actually a basic routine that prints a hex value out in decimal. So it actually takes quite a shortcut there. Okay, so we don't have to go into great detail on this, but just to give you an idea of all these extra features that have been packed in here. One last thing we'll look at is here at FBC0. This is where all the function keys are checked. And this is how the shortcuts are done. When you press F1, F2, F3, etc., it just goes through and checks. 85 hex, that's the key for F1. If you press that, jumps to FBE3. 89 hex is the F2 key, F3, and so on. So that's all 8 function keys here. And if none of them are called, then it just returns. And this is where the processing for them begins. For example, when you press F1, here it loads the accumulator with hex 93 and then prints that. That's the character to clear the screen, which it does before printing the directory. Or here, if you press F2, which restores the screen and cursor colors, it jumps to FBFA. So we can look at that one. And very simply, it just stores color C in both the border and background colors. That's the gray that we're looking at here. And then stores color 0, black, in the cursor color register 286 and returns. Very simple. Okay, so that's a look at MASTEROM, which does have some interesting features in it. I'm probably not going to give up using Jiffy DOS or my Super Snapshot for MASTEROM, but I do like a couple of the built-in features. But what I think is especially interesting here, it gives an insight into how these kernel ROM replacements work. And I'm especially glad that this little bit of computer history is now preserved and documented. So make sure you go watch MindFlareRetro's video about MASTEROM, about how he rediscovered it. I think it's a really interesting story. And in that video is a little bit more exclusive analysis from me, which you might be interested in too. Thanks to MindFlareRetro for including me in this. It's been a lot of fun, and us hosers gotta stick together, eh? Okay, thanks to my patrons for their support. Thank you for watching. We'll talk to you next time.